Okay, welcome to the Solid Edge in action. So what we're going to do, we're going to look at the Solid Edge. We've got a few examples here of what we've done. These have been the data sets we've used for the last while. So let's just jump on to the next page on here. So what we're going to do, we're going to look at what we've got within the Solid Edge portfolio. So on the left we've got the mechanical design, different levels of packaging we've got and the extra things we can add on there. Electrical design. So we've added those in the last couple of releases, and it's slowly kind of becoming a full package, so we can offer anything. Simulation we've had before, so we had simulation, we had FlowEFD added a couple of years ago, and now we've got some more advanced options that we've got available this year. Manufacturing, so we've got Solid Edge CAM Pro Turtle Machining, 5-axis, and then we've got other additional add-on ones on there. New one that we've got coming with the next version is Solid Edge 2D nesting. So if we're doing sheet metal work on a nest, we're a good nesting tool that allows us to nest and then even nest within the scrap as well. So it's really good. We've got Solid Edge illustrations and 3D publishing. Same program, apart from it allows us a single page or multi-page option. And then another one we've got coming is a PDF-based Solid Edge model-based definition. So the future is going to be no drawings. So the idea is you put your model into here. And it takes all of your information that you use to create the model and all the information you put in there, or the PMI information that you've got on there to create a model-based definition on there. You're about to switch on the views, spin it around, put all the information on there. Solid Edge data management, we've got the scalable data management. So we've got inbuilt data management, which comes with the product, which we'll look at in a bit. We've got a little video of that, little demo video to come up with that. And then we've got Teamcenter, so this is scalable as well. So we've got rapid start, quick option, and then we've got full deployment for full enterprise solutions on there. We've also got requirements management that comes in, so that uses our Polarion option. This actually integrates with Solid Edge, so it allows us when we make a change, it's gonna give us markers and know when we've made those changes. And something that I'm actually really excited about is Solid Edge Portal. This is constantly being developed. This is on a continuous release. So this has been updated recently, just at the start of July 2019, to add some extra ones. With the release of 2020, we're actually going to get options to export for AR as well, augmented reality. So that's going to be really good. So next slide. So what we're going to look at today, we're going to look at, obviously we've got loads of customers. We can see there Cadbury's, Waitrose, Sainsbury's, Aston Martin, some of the big ones, but we're going to look at this Master Mover. So this is a tool that's being used for moving big stuff such as buses, and also used for manual handling in warehouses. So this is what we're going to have a look at. We're going to look at redesigning that little component that we can see on the middle of there with a couple of bolts in it. But we're just using this as a kind of guide of what we can do with Solid Edge. So what we're going to do in this demo, we're going to look through part design, part drawing, assembly design, assembly drawing. We're going to have a little look at the simulation options that we've got. I've actually expanded on this a bit over what we've done before, showing you the different ways we can do it. And then we're going to look at data management. And then there are some extra videos that we can go through on there, which I may or may not go through depending on what you ask for. So what we're going to have a look at is redesigning this mount. So we can see there's a very simple mount on there. We're going to use our synchronous technology to make this really quickly. So people always ask about what this synchronous technology is. So what we've got, it's a specific Siemens thing. So previously we've always done history-based modelling, dimension-driven, highly automated, feature-based, and then it's got some negatives. So it requires pre-planning. You need to think, am I going to do that? So you'll see that from what the example I'll cover in a bit. Inflexible. I can't just make a change to it as it is now. Otherwise I end up increasing my feature tree. So I need to go back and think about how I do it. It scales poorly on many featured parts. As we start to build it up, it starts to rebuild time, which we don't want. We're about to just move those two faces and those holes follow. That's what we want. So previously we've had direct modelling. So we had the pros, flexibility in, scales well on many featured parts. Just drag it and we can decide how it's going to move. And we've got direct interaction with the faces. But then we've got some negatives. We've got no features. We have to rely on the faces. Weak dimension driven editing. Normally we have to click on a face and move it. We have to know exactly how far we need to move that face. And then there's been little design automation. So when we drag it, we don't know what everything else is going to do. So then we've got our synchronous technology. It takes the best of the history based, the best of the direct modelling. And then we kind of, we had procedural features. So we had featureless and direct modelling. We've got procedural features. So it allows us to get an idea of how we built it. 3D driving dimensions. So if you want to control something, we can put a driving dimension on. I want to move that face, I want to move these two faces equally. Got some really nice tools on there. 3D face relationships. Because we haven't got the sketches controlling it, we put the relationship directly on the model. Why do we need a sketch? The sketch is just to create the solid in the first place. That's what we really want. We want 3D face relationships. And then we've got design intent. If something's been created symmetrical, we want it to remain that. If we've created it with an offset against another surface, we want it to remember that. This isn't something that you've got to put in. This is something that is recognised as you start to move a face. It's going to look at all the other faces in the model and go, actually, I'm gonna keep this there because that's the way we're going to do it. So these are all the things that we're going to run through when we go on our through the demo. So what we're going to do, we're going to look at the little demo now. Okay, so here's the master mover. You can see we've got that component we looked at missing, got a few other bits missing, a few other little things we're going to look at, but we're going to split this into a few sections. So we're just going to have a look. So at the moment, we've got sub-assemblies, so if we want to hide certain parts, we can just hide them on there. We've got these view configurations, so we can see just certain components, so we just click those on and go on there. So just click all, so we can do everything. I don't want that, I'm just going to hide that again, just so we can see. So this is where our new part is going to go, so we're going to clip in between there and there, so we can have that new component. So what I'm going to do, I'm just going to create a new part, so I'll decide what kind of part I want. So we haven't got a huge amount of templates on here, we've got lots of different standards that we can go to, but I'm just going to do an ISO on here. So I'm going to create an isometric part. This has come straight into the synchronous mode, so real quick way of doing it. So the first thing I do is do a sketch. So notice we've got our sketching tool straight on our home tab on there. So I'm going to sketch on that top surface, 34mm, and then I'm going to sketch a rectangle as well. So I'm going to go on that same one. We can use standard Windows shortcuts on here. So on this one, I'm just going to tab through 25. That's going on there. At the moment, we've got an angle on there, so I want to make sure there's 0. And then I'm just going to leave that size roughly there. Notice this has now created regions. So rather than having to define it, we could select one of those regions and do it, but great thing about Solid Edge, we can just select all those regions together and just select that arrow. That's then going to recognise how I want on there. Got a quick keyboard shortcut if I want to change it to symmetrical or not. I'm just going to drag that up on there. Notice that the dimensions that we put on there have migrated across. We haven't got that dimension, so that doesn't matter. We can just add a dimension between those two lines. That's going to allow me to pop that dimension on there and just set that to 100. So that's my size. So the dimensions aren't actually in the sketch; they're actually model driven. So that's going to be deciding that from the that's going to be controlling the model directly rather than having a sketch that's controlling that model on there. So next thing I want to do, if I want to extend that face, I don't actually want that to be 100. I actually want that to be 80. So I'm just going to drop that down to 80. Notice we've got the direct model interaction. So on here, it's picked up symmetrical because we built it symmetrically at the start. But I'm going to turn that off just with a quick keyboard shortcut of S. Is then going to allow me to make that change on there. So that needs to be 130. That's the right size on there. So next thing I want to do an extension that goes up here on the bracket. Here we just need a simple line, and I'm just going to do a line across there. That's then going to create two regions. As soon as I finish that line, it's then created that region. So overall on here, I want this to be 150 high. We can do calculations in there. So I'm going to do 150 minus 34, the height we've already got. That has then added that part for us, how we want on there. And then before we make any changes, I've just realised this doesn't look quite right. That size on there, that 34, that should be 50. 34 should be the ID on here. So even though we've made a little mistake, it's easier enough just to go and make that change. So that's the size that I wanted on there. That's good. Any of these dimensions, I know 25 is exactly what I want. So what I'm going to do, I'm just going to click on that and just make sure that gets locked on there. So that one's not going to change. So we can lock dimensions the same as we would fully define a sketch if we're in a part. Next thing we're going to do is do some rounding. So hopefully we want to rounding rules, starting large and working our way down. So I want to start with these two edges on here, that one and that one. I'm going to do 40. on those. Then I'm going to shrink down to the next size. So I'm going to do 15. Notice we can't change these until we do that. So I'm just going to do 15 and tab, so it doesn't finish those. I'm going to do that one, that one, that one, and that one. Notice I can select directly through the geometry. For me to have to spin round on there, I can just select those there and then just finish those. So next one, I want a small one on the inside here. So I'm going to do that one at 3. And the last one, I'm going to choose all external rounds. So fillets will be internal, rounds will be all the external ones. So click on that part and do all those will be 2. So we've got the part on there now. Now we need to put some cutouts in. So we're going to use our sketching again. There's no need to define any planes or anything. I can just hover straight over there. Notice that's telling me to use F3. And then I can orient directly to there. So I want to do a rectangle. So this rectangle will have approximately that kind of size on there. We can use our sketch alignments. So I want that to be centered to that. We can link that to that. I'm going to put a circle from the start as well. So remember, we made that mistake before. So I want to do 34. So that's the size that I want on there. And I do another rectangle. So I'm just going to snap on there. So this is going to be for the cutout on there. So that one, I'm just going to take that just to the midpoint on there. So I'm not really worried too much about putting sketch relationships on here. It's all about getting this geometry in there quick. Then what I'm going to do, I'm going to select those regions. And I'm just going to use Control, same standard window shortcuts to add those 2 extra regions that I've got. And then I want to drag. So when I do it that way, so I can use the standard keyboard shortcut Shift, because I'm going to change that. As soon as I do that, it realises straight away how I want that to go. So I'm just going to drag that all the way through, and that's then going to put cuts through top and bottom on there. Okay, so now we've got a cutout in there. Realise that when we put this cutout on, again, on the fly, we didn't actually put a dimension on there. So I'm going to go and control that one. There's a little button I can click on there. 45. Our round's moved with it nicely. So that's the way we want that. So next thing I want to do is try and line these up. So we didn't do this in the sketch. We can do this using relate tools on here. So I want to relate that face to that face. Okay, see on there, those have moved. We turned our symmetric off, but we actually want that back. So I want to press S again on the keyboard. That's then going to allow that. So notice we've got those faces are now moving with it. It's highlighting that we've got faces that are moving with that. So that has now related those faces and kept those faces the same. So we can now pop a dimension on this cutout. So I'm just going to select 2 of those edges. So that edge, and drag that out there. So I want to do the middle option again. When we do these, if we come out and click back on, it will remember what we've done. So I'll make that change on there. We're going to allow those to move. So that's not the size that we want. 8 on there. That's the size that we want on there. I'm just going to drag this a little bit deeper as well. So I'm not too worried about what the size is on there. I could pop a dimension, but as long as we've got enough clearance for the holes that are going to go in. Actually, I'm just going to drag that and just snap that to a key point. So we can just snap that to a key point. That's then going to remember exactly where that is on there. So we're happy with that. So next thing we want to do is put a hole in. So we need to put the mounting holes. So we've got the adjustment on there. So we've got a real nice simple hole tool. I can pop the hole in first. So I'm just going to press the F3 to make sure we're locked to that plane. I'm just going to snap to that endpoint on there. So that hole has done a through all straight away. Now I've got that hole, I can click on that size and just make a change on there, 10.5. It's going to allow me to do that hole really quickly. So now I'm going to pattern that hole. So select the hole, select the pattern command, just drag up the direction that we want. Click on the arrow. We want that to be the X direction for the pattern. So it's got 7 and 1, which is the size we want. We actually want to have a 20mm gap. And we want this to be a fixed size. So we're going to do a fixed size, 20mm gap, 7 and 1, and then accept that. So we've got those holes going all the way up through there. Okay, so the next thing we want to do now, actually the reason we're doing this was because we actually want a slightly different one of these. We want this tilted back 5 degrees. So because we're synchronous, we can do that change. I haven't got to go back and make a change to one of the initial protrusions on there. So I'm just going to select that on there. So that's selecting everything that I'm interested in. I want to go on there. My design intent, I'm just going to restore that. just press R. Nice simple shortcut again on there. And I'm just going to make that change on there. And I'm going to drag that back 5 degrees. Just pop 5 degrees in there. That's made that change. All those faces that are highlighted are all going to remember their position. So it's a way of kind of temporarily locking those faces together. So we've got that one. It's going to hide all the PMI on there. Another cool thing, if we click on a face, it's going to highlight any PMI that's affecting that face. So we don't need to be PMI busy on there. I'm just going to put a smart dimension on here now. So I've got that at the moment, but I actually want that to be a diameter. So I'm going to change that to diameter dimension. And I'm actually going to put a little bit of information in there. So I'm going to put a little bit of unit tolerance. So I'm going to have 0.25 and 0 on there. This can actually be pulled into the draft as well, so it's really useful that we can put that on there. Next thing we're going to do is we're going to add some material. So I'm just going to click on the material option on there. So I'm going to find some materials on here. So we've got metal, aluminium alloys. That's not the one that I want. Let's find the one in here. Aluminium alloys. I'm going to put aluminium cast. Okay, apply to model. So it's going to make that look cast. We've actually got some machine parts on there. So I want to be able to show a nice view on my drawing like this. So what I'm going to do, I'm just going to paint those. So I'm just going to find a nice silver, nice little option on there. Notice we can paint features as well. So if I select the cut, I want the entire cut out to be silver. Select the whole. And we can't get the pattern, but we can get the pattern from there. So notice we've got features in our history on there. So that allows me to do that pattern on there. So that's showing all those. There's all the machine surfaces that I want. Next, I want to check the weight on here. So I'm going to go into my properties, update, 475, happy with that. I want to be able to see this live as well. So what I can do, I can use a little call out on there. I can find this on here. So what I'm going to do, I want to find the mass from the active document. So I'm going to select the mass. Okay. Okay. That's shown that already, and I'm just going to link that up to there and leave that on there. Okay, so you can see. So I'll pass you back to the whoever's presenting for you, and we'll go through and we'll see what we've just done on there. Thank you. I'll speak to you in a minute. Okay, so that was the Solid Edge part design demo. So what we've seen there was in synchronous technology, best of both worlds modelling. It's got the robust Siemens Power Solid engine. So this has been developed by Siemens and it's used by multiple other CAD software, other ones that may start with Solid as well. And then it's got the exclusive Siemens synchronous technology. So Solid Edge is the only one that uses synchronous technology to its full potential. It is used within other Siemens programs, but it isn't used quite the same way that it is within Solid Edge. So next, let's have a look at a part drawing. So we're going to add views to clearly communicate our design. We're going to retrieve dimensions from the 3D part. We don't want to put them on again if they're already there. And then we're going to add further dimensions, extra views, and annotations on there. Okay, so let's look at taking a draft from this now then. So I'm going to do a quick little icon. I'll take this straight into our drawing board. It's going to prompt me to save it. So I'm just going to save that first. We've got built-in data management or normal data management, so that's just going to take the next number on there. So that's going to take it into there. So I'm then going to bring that part in. So I've got a save setting for top, front, right and an ISO view on there. I'm just going to go onto my settings and make sure I've got hidden edges in there and tangent edges in there. So I've got those turned off. So that's going to show me a preview on there. I've got this little button for best fit. So I'm just going to do a best fit. So I'm just going to create those views on there for me. That one we added that nice cast look, didn't we? So I'm just going to change that to a shaded option on there, and then let's update that view so that then shows nicely on there. I'm just going to scale that one up to the next scale option. Okay, so we've got that one nicely on there. Let's see if these will work on that scale option as well. Okay, no, wrong way. Okay, it's a little bit big, so let's just go back to as we were on there. So we've got those scale options on there. I'm not too worried about that view, so I'm just going to delete that view. Next thing, I want to try and get some of the dimensions. So we've got an option where we can retrieve them. So we've already put some dimensions on the model, so we don't really want to be doing that again. So I can then click on those, click on the views that I want to retrieve the dimensions. Like I say, I'm going to show those dimensions on there. These are then editable, so I can drag that. I can decide where the handles are going to snap onto. I can move those dimensions if need be, or I can remove them and place those dimensions back on there. So I can click on there, drag in the other way. I don't need that one because that one's a copy. And we can manually put dimensions on as well now. So I'm just gonna select what I want. Select the different points to make sure we get those dimensions that we need. We can select that on there. I've got an option for a hole call out, so that's gonna pick up that hole for me straight away. I've got 7 of those, so I'm just gonna go into my option and add a little option on there, or I can say coplane. Yep, so that's quantity all of those. I'm gonna add that, not in that one. And I'm just gonna put it times and then paste that value back in there. Apply OK. So saying we've got 7, so that's automatic. So if we did go into the model and make a change on those, that's going to make that change. I do another smart dimension. I do an automatic axis, so I'm going to pick the centre of there to the centre of there, and I'll just use Shift key just to change that. So that's automatic. That allows me to do a little override, so it allows me to pop that little dimension in on there. We can do angular dimension via there, so I can select one line, press A to change that to an angle. When I select the second line, that's then going to give me the angle. Really nice way of doing it. So next one, I'm just going to put a little dimension on there because we've popped that one in there, haven't we? We've got our height on there, we've got our drill size. Let's just put a couple of extra dimensions on here. So we've got a dimension from there to there, and then we'll do the last one. We'll just do it to the end of that slot on there. So for this one, to add another one, I'm just going to pop that on there. Not really the ideal size, but we could easily go back and make that change in the synchronous just by selecting that face or adding a dimension on there. So next thing, I'm just going to put a detail view in. So this is really quick. So we just select the area we want to create the detail view, select that on there. We could do a fully defined detail view on there, but I'm not too worried about that. And then I'm going to place that view. I can then pop my little round detail on there. So I want to try and keep that in the box on there. Okay, so I'm going to create a auxiliary view. So I'm going to create an auxiliary view. There's on here I can snap to a line. That's then going to allow me to take a view off there. What I'm then going to do on there, I'm then going to alignment on there. I'm going to click on that alignment. It's going to allow me to move that view out of the way and put that over there. I'm just going to drag this box and just shrink that box down because I'm only interested in that section on there. And I'm just going to change this a little bit so it looks a little bit neater. So I want that to show where that view is going to be. It's only picking up there, so I'm just going to drag that on there. That's where my view is. And click back on that view. So that's on there. Okay, I want a little box on there. So I'm just going to go onto my view properties on there, and I'm going to show the drawn view border on that one. Okay, so that looks nice. So we can then show the information on there. So I want to show this slot information on there. So I want to use that automatic between those two lines and add that little dimension on there. Just going to make sure that view is all updated on there. So we've got the detail. Last thing we're going to do, we need to do a broken out section. So I want to show a broken out of what this looks like up on the top there. So I want to do so for the broken out section, I'm going to find the view. So on there, I'm going to do a little curve. So I want to show this. I want to show the section that I want to be breaking out. So I'm going to create a curve, go around those. I'll do. Close the broken out section. And then I'm going to define the depth. So I'm just going to snap to a midpoint on there, and then I'm going to put the broken out section on that view. That's then going to show that broken out section on that part. Okay, so that's some of the basic drawing commands. We'll cover the assembly ones in a little bit. Notice that we've got information on the drawing border as well. It's showing our mass, our material, and once we save it, we're then going to get our title and revision information appear on there. Thank you. Okay, so what we've just seen is the part drawing. So we've seen fast view creation, automated production ready dimensions are already on there, a few extra added on, and it's clear and accurate, and we do this to standards as well, so we can make sure that this is to your company standards. So next, let's have a look at assembly design. So what we're going to do, we're going to assemble with nuts and bolts, and then we'll look at interference, and we'll look at copying and pasting. So we're going to go, actually, we've already got that there. I'm just going to copy and paste that from one to the other on there. Okay, so we've got our part drawn now, so we're now going to insert that in here. So we're going to assemble it, and put some bolts in, and then we're going to have a look at a few other little things on the assembly. So we're going to do all this in one hit now. Okay, so I'm going to just insert component. I'm just going to find my little option on here. It's really nice, it recognises the last place I saved that part, so the part that I've got was 672. So we've got that one. So I'm just going to drag him in there. Once it comes up green, that means it's ready to assemble. So I can just click on the faces on there, and then click on the face I want that to go onto. So that's the first face I want there. I want the second face to go onto the back side of that. And then the next, so I want to do a couple of these holes. So we've got that hole. Notice how that part is moving to suit there. And then that hole to that one. Okay, so that's made that change. Last little one, this underside face onto that. Okay, and that's now gone solid. So that means that is actually fully defined. Notice that the pipes, the hoses on there have updated automatically on there. So that part is now in place. So what we're going to do is put some fasteners in there. We've got a real nice system on here called the fastener system. So on here, we're going to open up the fastener system. It's asking for the top holes. So on that one, actually I don't want all of those. I'm just going to do a single. So I'm just going to select that one and that one. Because we've got the adjustment, and then we've just got to define a bottom hole. So we know the clamp depth we're going to have on these parts. This is then going to look into the fastener system database. So let's just give that a while to load. Okay, there we go. So we've got the correct standard. We want a DIN standard on there. We did 10.8, so I want to be at 10. We can decide any kind of different kind of bolts. I want to do a button head socket screw on there. 7380 M10. Now click add fastener. So that's saying add fastener on there. Minimum extension coming out the end of the bolt is going to be 10 mil. So then I've got my top stack. So I'm just going to look for a washer. So I'm just going to close that one, change that washer. I'm going to do a 12518 10, add that one, and then look on the bottom stack. So I'll do the same. I'm going to find that same washer and pop that one on the bottom. So we've got our bolt, top washer, component in the middle, and then we've got our bottom stack on there. And then I'm going to find a nut on there. So I'm going to do a hex nut, American. So I want to use a nylock, non-metallic insert, then 982 M10. Recognises that because we've got an M10 bolt there, and then that fastener on there. And I'm going to click OK. That's then going to generate any bolts that we may not have used. So the washer and the nut probably used before, but it's a new bolt, so that's just going to generate that. So that's looking at a template part and adjusting the sizes, and that's going to pop all those in there for us. So we can go back at any point, back to that step and define, so if I wanted to reduce the depth on those, but I'm actually quite happy with those. So that's bolted in place. So next thing we're going to do, we're going to have a little look at one of the sub-assemblies. So see this sub-assembly, we've only got the one caster on there. So I'm just going to hover over that so we can see it's that one. And I'm just going to click open. So I'm going to go jump down into that sub-assembly. So we need to copy that over from there to there. So synchronous. We can click on there. We can use the steering wheel. So what I want to do is just find the center point of one of those components. So I'm just going to hover over until I get a center point. Hit the copy command. So we're going to copy all of those, and then I'm going to drag that over and select the round on one of these components on here. So that's going to copy. So I'm just going to find that round on there. Okay, 170. I'd like to see a nice size like that. It means we've got an accurate copy on there. Then what we're going to do, we're going to remove the relationships from there, and we're going to apply them over here. So once we do that, that's the part we're looking for the relationships. Accept. That's then going to copy those parts, and it's going to create those relationships. So we had no relationships on there, but it's using those relationships copy. So a really quick way. So if we did change that part, it's gonna match up on the other part. Okay, just save that one, and then jump back to the top level. So next thing we want to do, we're going to do a bit of an interference check. So we're going to work on this component on there. So I'm just going to hover over that, see what highlights up on there. It's that one, and open that one up. Okay, so what we're going to do on here now, within the inspect tools, we've got a little check interference option. So on here, I'm going to check interference against itself. So we're just going to check these parts. I'm just going to highlight everything and do an interference check on that. So we've got a few holes. We've got a little part there that's catching on the spring. So we can go in and make that change if we think that would be an issue. But in reality, that spring would just move and that would push across. So I'm not too worried about that. But what we need to do, we need to check interference when we're actually moving it. So we've got an interference checker built into a drag component command. So when we click on that, we're going to, I'm just going to select one of the parts. That's going to allow me to drag that. So that's dragging it at the moment. You see that spring that's adjustable is then going to adjust on there. We can do that with detect collisions as well. I drag that, it's going to highlight and it's going to ping at me and tell me that there's an issue on there. So straight away we can see there's an issue on there. So I'm going to drag that back. And I'm just going to escape out of there. So what we need to do, we need to make a change. So this is something else we can do in synchronous. Even though we're in the assembly, I can tell it that I actually want to look at part faces rather than parts themselves. So I'm going to click the face priority. That's going to allow me to select that face straight away and change that value on there. I'm just going to click that face only. I'm going to change that to 15. So hopefully that's going to clear. I'm going to do the same on the other side. And change that one. These are slightly different because we've got a counter sync on that side and not on the other side. So I'll change it to 15. And then we're going to run that same drag component command again. So I'm going to click on that bar and drag that. So we haven't got the same issue. See, we've got some of the little issues we had before. Solve that main issue on that part. And I'm going to escape out of there. So I'm just going to save that. Now we've fixed that one. I made that change. So no going in and out of different environments. A big benefit of synchronous. So I'm just going to save that one. So let's just jump back to there. So we've done that change. We've done that change on there. I want to show this part as well. So that's some of the things we can do. So we looked at assembly. We saw the hoses automatically updated. So that's part of one of the tools. We've got ExpressRoute where we can create those. We've looked at doing the interference checking on there. We've seen copy and pasting. We've seen that one on there. So next section, we'll look at doing a draft of that component, but that'll be in the next section. See you in a bit. Okay, so that was assembly design. So we've automated fastener library, assembly fit and function validation. So we did that drag component, made that change on there, and then we've got that rapid top-down design. So we just copied that caster from one over to the other, and we've copied that from one way to the other. So next we're going to look at assembly drawing. So we're going to use an assembly exploded view, create a parts list with balloons, and then we're not going to do share drawing with a non-solid user, but this is really simple using the save option. So we can save this. We can actually have Solid Edge as a unlicensed product, and people can view it. So they can have Solid Edge on the computer and they can view parts. They just can't do any of the design work. So it's a real nice way of doing it. Okay, so next we're going to create a draft for this component, assembly even. So I'm going to do my nice quick link, go straight to my drawing border on there. I only want the one view on there, so I'm just going to click on there and just say I just want a single ISO view. So that's the view that I want on there. It's actually the wrong way around. So I'm just going to jump on there and allow me to see what that is. So I can use my view cube and go, no, I don't want that way. I don't want that way either, so let's just try that corner. There we go, that's the one that I want. Close and OK. So that's my user defined view. It's going to change for me automatically. So that looks quite nice, but I want it to be colour. So I'm going to put it straight on that option and then update my views for me. We've got the black and white option as well. So I must have clicked on the wrong one. Let's do that on colour. Show you the edges. Okay, that looks how we want it. So on the first view, I'm just going to show this with a parts list. On the second one, I'm going to show a parts list with an exploded view. So it's really important that we can get a parts list. So when I go to a parts list, select the component that I want. That's then going to create a parts list on there. I've got loads of different options that I can go on here. I can choose. I've got lots of different saved options on here. So I'm going to do a bomb parts list on here. Okay. That's then going to create a parts list on there with all the information that I want on there. So I may have keywords. This is all customizable, so there's no need to put those on there. So I'm going to go in there, have a look at the ones that I want. So I'm just going to, let's just go to my columns and say, so I don't want keywords, I don't want category, I don't want my manager one either. Okay. So even though I based it on one, that's allowed me to customize that component. So I've got all the information I want on there. If I want to turn that into an indented parts list as well, we've got the option where we can do an exploded. So I'm going to click on that one. That's then going to give me the option to show that as there. So that's going to show me those items indented, so I can see everything that I've got in that component. So next, even though I've got one parts list, I can actually add balloons to a second sheet. So I'm going to do a second sheet. I'm going to do a view wizard, select that same component again. I'm just going to click back on there, do a dimetric this time. So that's the component, and let's just spin that one around so it matches, or almost matches the one on the other page. So I'm going to go this way this time, just so it looks a little bit different. Okay. So on here, I'm now going to find the exploded view. So the exploded view has already changed. So on the display tab, I can find out any display configurations, and I've already got an exploded view version. So when we do the auto explode command, it uses your assembly relationships and just creates offsets on those assembly relationships. So as long as you've built that part nicely, it's going to look quite nice on the explode. So we've got that explode, fits quite nice. So I'm going to create a parts list, but I'm only going to create the parts list on here. So it creates some balloons for me. So notice I've got an option for an auto balloon on there. So that's going to create the balloons on there. So I've now got all the balloons on there. I don't actually want that parts list, so I want to delete that, but the balloons are still going to stay. So I've got the option on there. I'm going to do a custom scale on here, just to shrink that down. And I'm going to let's give it some colour, so it looks the same as the other one. So we've got all those items. We've got nice little balloons on there. We can do lots of other things. So we can decide how the balloon numbers are going to work. And that's then going to adjust on the parts list for us as well. So we've got loads of control on there. So very simply, we've got the component showing how it's going together, and that one on there, and then that's showing the parts list as it appears on there. Okay, and we can save that and use that downstream. The parts list information we can physically write on there. We can do copy contents, and we can copy and paste that straight into Excel if we need to. There's no need to go into any other way. We can copy that straight away like that. Okay, thank you. Okay, so that was assembly drawing. Drawings monitored for model updates. So if we do make a change, did you notice we had grey borders appearing? So these are showing that something's changed on there. So if the models do change, we've got that automated parts list with those quick balloons on there. So a really quick way and nice way of doing it. And the views look nice and clear in those colourful, with those colourful drawings on there. So next we're going to look at simulation. We're going to virtually test to ensure required strength, make any changes and retest, and then we're going to show how we can create a report on there. Okay, so we're going to look at some simulation now. So we've got this component, fixed place there. We're going to add some force onto the two holes. So we're going to do a new study on here, decide on how we're going to do it. Just going to change that option. So we're going to decide what the material is. Cast aluminium isn't actually the best strength aluminium we're gonna get. So I'm just going to change that. We added the cast just so it looked nice. I'm just going to put a 7075, which is a high strength aluminium. I'm just going to put that information in so it's going to look a little bit different on there. It means that we get something a little bit more realistic. So we're going to define what we want. We've only got one body, so we're just going to accept that body. We're going to look at the force that we're going to apply. So I want to apply the force to some faces. So I'm just going to select 1, 2, 3, 4 faces. I'm going to grab this, pop that on this circular face on here. Stop it jumping, and click on there, and I can just decide where that force is going to go. So you can see where that's going to go on there, and go, okay, I want that force to go somewhere around there. Now I'm going to put 200 kilograms, so this is newtons. I'm just going to 0. I know it should be 9.81, but for this, that's then going to convert it in there. So remember, we've got standard kind of forces on here, newtons, N-M for newton meters, for if we're going to have a torque. So we're going to do the force. I'm not going to worry about any of these additional loads. We're only doing a physical check, so there's no thermal loads available. And then we've got fixed, so fixed in all degrees of freedom. So I'm just going to select those two faces on there for those to be fixed on there. So that's all we need is a fixed and a load. We can add more, but obviously the more we add, the more loads, the more fixed points with different relationships, the more complex it becomes, and the less chance it's going to solve very simply. So I'm then going to solve. This one shouldn't take a huge amount of time, so let's just allow that to run. So once it comes up processing results, we know that we're all done. Okay, so that tells me that's done on there. So we've got our yield stress is shown down here in the bottom right hand corner, and we've shown what our maximum stress is on there. So we're actually really quite good on here. If we'd have had the previous material, which was around 30, we'd have had quite a few points around here that would have failed on this component. So we can do a maximum marker. So that's going to show us where that maximum point is on there. So that's actually a little bit high, so what we'll do, we'll go in and change that, but I'll just show you a few of the other things on here first. So we've got stress, displacement, so we can show where that highest displacement point is, 0.217. So that's 150 up there, 0.217 is less than 1/300th of that value, so I won't be worrying too much about that. When we're doing the stress, we can view it many different ways. So we can do mean stress. Von Mises is probably the one that most people tend to learn. We can have a look at the actual deformation. So that is kind of giving us a exaggerated deformation when we look on that one. On the display, we can decide what it looks like. So we can have an external. I quite like the model one, so it looks a little bit smoother on there. We can decide the face colour. Well, put it back onto the standard external mesh. On the colour bar, we can obviously add these minimum maximum markers. We can do a use define scale. So if we're only interested in stuff above that 30, we can go. I can put that value to 30, and that's then going to change those colours. So we're not going to see the rest of the graduations on there. We're just going to see those options on there. We can see this several different ways. So we can see thermal grayscale. I quite like the spotlight one. So it gives us green. Very nice, easy way of seeing it. So it's going to give us a spotlight on the problem areas. If it's the wrong way around on the structural one, so if I do no magenta, we can invert the spectrum. So it's just going to spin this round the other way around. So if it's not in the colours that we want, we can change these. If we're getting scientific values up here and we don't like those, we can click on there and turn that to a normal floating value. So we can just change that and decide exactly how that's going to look. So that's the main things on there. So I'm just going to close out of here. So we've got 71.6. I want to try and knock that down a little bit. So we've got a factor of safety of 10 on this. Very, very high factor of safety. We're going to try and get on here. So I'm just going to click on there. Change just that value. Yeah, we can just about get 8 on there. I could add rounds to some of these corners to try and make sure we don't get any point stresses on those, but I'm not going to worry about that. And then everything else is then going to update. So I'm just going to run back on solve. So it's remeshing. So it's going to remesh with that change that we've got. We're going to solve, and we're going to be keeping an eye out for that high value that we've got on the right on here. So results, it's worked, it's good. So we haven't quite managed to get it as low as we wanted. 72.5. We're still what's that factor of safety between 8 and 9 on there. So we've still got a really good factor of safety on there. So other things we could do, we could reduce the depth of that slot on there. Probably a little bit too much slot on there. We could add some small rounds on there to try and get the best out of that. So that's the normal one. So if you don't want to see any other ones, end the video there. I'm going to show you a few of the other options. Okay, so we've got simulation, that's normal part. We can do sheet metal as well. So this is one that I've already set up. So what we've done, we've gone and done a mid-surface, created a mid-surface on there. So when we've got a thin sheet metal, we're not going to fully calculate it. We're going to treat it as a single mesh, and then apply a factor of the strength of that mesh on there. So it's a much quicker way of doing it. So when we run this, we're going to be able to do that as a quick mesh. You can see just how quick that one was. And then we can see on there, we've got the same kind of bar on there, and we can see all the information on there. So we've got the different kind of spectrum, spotlight, so we can see the green, and we can see those options on there. So another one that we've got, we can do a full one. So on this we can use bolted. So notice we've got bolted plates on, and then we've got a welded on here. It's a little bit more complex. You can see the amount of connectors I've got connecting all these. So I've got a sub-assembly there. I've had to connect all those together first. And then we've done a couple of bolted connections on there, and then I've added a floating connection on those ones. So if I now go and view the results on that one, so we can do all those parts together. already changed the colours on this to remove the magenta on there. Now if we just change that to the model display, it's just a little bit smoother. What else we can do on this colour bar? We can do user defined scale. So at the moment that's very difficult seeing what those are. So if I change that to, I think it's 450, there we go. So change that value on there, so we're only showing up to there, so it's going to show us much more where those are, so we can see straight away that we've got slight compression issues down there, a few issues on the back there, but most of it is around these welds. I've actually done the weld stitches on here, which we could simplify the geometry and get rid of those, so I wouldn't be too worried, but maybe it might be worth putting an extra couple of ribs just in that place just to get that how we want on there. So the last one we're going to do is frame. So if we look at frame, I've created this little frame on here. So I've done it lopsided, put a couple of diagonal struts on there on that side, so we're going to clearly see the difference with the struts and without the struts on here. So we do this from the frame tool. So I'm going to go into the frame tool, obviously we normally come in there, so we'll be in the simulation tab. I've already done all this, so you can see how it's connected all the frames up for us. And if I jump over to those results, I've put quite a large load on here. It's quite a large frame section. This is 6 by 4 meters by about 3 meters tall. We're still well within the stress range on there, and we can see exactly how that's going to look. With this one, this is probably one of the best ones for showing animate. So we can actually show how that animates as well, and we can save that as a film. So we can go in and show that. On these, one of the good things we can do, we can create a report. So we can create a report from this, simulation report. It's going to give you your author tag for your windows, your date. You can put additional information in, you can put that in here, you can put it in afterwards. If you browse to a logo, that's going to remember that logo next time we do a report. And then we create the report, you can see that's then going to go through some of the different screenshots on there for me. So let's just leave that to run, watch the screen flash through the different options that we get. And then that's then going to open a simulation report for us. So I've done one as a Word document. So it's going to give you information, it's going to give you the version that you've got. So it's quite nice to see. So I've got 2019 with maintenance pack 8 on there. The version of FEMAP gives us all the model information. It's a really good way of checking what we've got. So we can see what beams we've got. So we can see I've got the spec, I've got all the correct information in there. We can see the spec of the steel, the loads that we've applied. So we can just double check that we've got those. Yeah, that's all correct. I've got body temperature and gravity on that one. We can see the constraints, fixed degree of freedom. We can see the mesh that's been created, and then we can see our results. So we can see our displacement and our stress values on there, and then we're going to have the picture that we've got on there showing those stress values with the different pictures. This is editable, so we can go back in and add any conclusion and disclaimer afterwards on there. Okay, that's the end of the simulation bit. Thank you. Okay, so we've looked at the integrated simulation for design and engineer use. So you may have somebody that uses a specific simulation tool externally afterwards, but the idea is this is kind of, it works as you're designing it. Reduce physical prototypes material cost, and this leverages renowned FEMAP and Nastran. So the one you've seen I've expanded on a little bit, so I've shown a little bit of sheet metal, a little bit of frame, a little bit how we can do it in the assembly as well. So showing that we've got lots of different ways of doing it. So next we're going to look at data management. We're going to navigate data simply, quickly finding files. We're going to easily make design revisions, and we're going to collaborate effectively. Okay, so let's have a look at some of the data management tools we've got in Solid Edge. So from ST10 onwards, we've got the Solid Edge Data Management tab. So on here we can do all of our basic tools, and then we've got an additional tool called Design Manager. So whenever we open a file, it's always nice to kind of just do a few options on there. So I'm just going to click Get Latest. So look for any new revisions or any parts. So we can see there's no new revisions on any of those. Simple ones, open drawing. That's going to go and look on the server. We're going to have the drawing on that part straight away. Nice and simple. If we have any sub-assemblies, I'm just going to hover over that to find out what that one is. We can do the same on there. We can do an open drawing, and we're going to find the drawings of these parts. So that's the one that we created earlier. So open drawing, we can do where used. So if we've got a component that's used elsewhere, we can click on that. It's going to pop up with a little box. We can then expand it and find out where that's used. So that one's got the drawing that we made earlier. It's also used within here. So we can see any nested where used items within there as well. Any of these items, we can right click on these and open these if we need to find out where they are. So before we do a revision, a where used is always a good idea on those. We've got different options for save as copy. So we've got save as translated built straight into there. So we can save as DXF, step format, any other options that we want as well. We can do a checkout. So when we're working on a component, so I'm going to jump to this part again, we can do a checkout. So notice that's then going to go green on there. So that's going to show that's checked out to me. If it's checked out to somebody else, it comes up orange. So we've got that clearly showing that's checked out, so we can contact that person and find out what's going on with that one. Just going to check that one back in on there. We can view the file properties on these parts. So I can click on any of these items. So we'll go back to that one and go on Property Manager. So I'm going to pop up with a box, and that's going to display all of the properties from that part. So make sure if we've got anything missing, maybe we've got none in some of these, we can go and check those before we put that into a draft environment. So a really useful tool on there. Okay, so next what we're going to do, we're going to add a part and then make a revise and change it. So I'm just going to hide that part. I'm going to find the part that I want we've got a search tool, so we can search the value, search where we want. And if we run a search, it's going to search and find the part that we want. So that's the part that we want. I'm going to pop that part on here. So we've got capture fit already built on there, so that knows exactly what we want on there. So I'm just going to go onto there, and then I'm going to select that to match that edge. That one's gone the wrong way, so I'm just going to jump on that relationship and just flip the relationship around the right way. You can see we've got a slight issue on there. So what I'm going to do, I'm just going to make sure I haven't got that on there. Just going to hide that and hide that. I'm going to make a little change to this. So remember, we can do lots of different options. So we can do this shortcut to face priority. So I'm going to select those two faces. I'm just going to drag him down and make a change on that. It won't let me do it because it's released that part. So I need to make a change on that part first. So what I'm going to do, I'm going to select that part. Data management, go to revisions. So it's going to create another version of that. Actually, that's telling me that there's already another version of that. So let's just come out of there now. Let's do my get latest. So we've got that one. So I'm just going to make sure that we've got that one on there. And then we're going to accept that one and check there's a later version on there. So somebody's obviously already made this change on here. So let's go and move those two. Drag that down 10 mil, and then show everything back on there. Actually, I don't want to show everything. Let's just hide that one again and see how we got on there. It's not ideal, but it's not brilliant. But close enough. I could drag that another 5 mil, but you get what we're trying to do on there. So we can make little changes like that, even though they're changed. So that's some of the main things on there. We've also got Design Manager. This is another tool. So this closes out of Solid Edge, allows us to move, rename, and do some other really big tools on there. So that's just going to pop up now. So on here, so we've got a Design Manager tool. It's going to tell us all these parts, allows us to make changes, revise. And there's a nice little tool on here that allows us to do an assistant, so we can decide what we want to do. We want to save, revise, move a file, replace it. And what that will do, that will tell us what our file names are, allow us to rename all those file names. We've got a real nice tool in here called Pack and Go as well. So it allows us to put everything in a single zip file and share a file with a customer or supplier as well. Okay, thank you for your time. Okay, so we've seen we've got organised data, efficient process management. We can actually do cloud-enabled flexible collaboration as well, so it doesn't need to all be on a server. We can do it on there. And we've got built-in capability, zero extra IT overhead. As long as we've got a server or we've got some kind of cloud-based server, we can run with that. So we've also got KeyShot. So here we've got a very basic KeyShot that's been based on here. This is spinning around just using name views. We just say I want to look at that view, and KeyShot puts it all together. Solid Edge puts it all together and then puts it into KeyShot. This comes with the classic and premium licenses. Really quick way of doing it. So what we've seen, Solid Edge with the synchronous technology taking the best of the history base and the best of the direct modeling and putting it together, adding some additional features to go on there. really important that we do leverage that synchronous technology. That's probably one of the biggest things. Other CAD systems may have certain clever commands, but synchronous technology can do everything that those commands can do. Just in a very user orientated, rather than running through a command bar, make that change. You just do it all in the direct. That means we're just interested in, as the model is now, I don't care about how it was made. I want to move those faces to there. I want to delete that section. I want to do that. You just do it all directly on the model. It's just the here and now, not the as I created it. So with this, it's going to give us accelerated design, more time to innovate, faster revisions, quicker time to market, click change, new ones there straight away for us. Better reuse for reduced engineering costs. So we've got some nice little quotes here. Definitely led us to a better product. Now what we can do in minutes, used to take us hours. Imagine a history-based model with 300-400 features in there, and you're changing 1, 2, 3. One of the first ones you created. The amount of issues it's going to create scaling back down that model. So it saves me days, literally. Yeah, it can do. I wouldn't want a model with anything else in any other way. So here's the packages that we've got. So obviously speak to your account manager for the details that you want. Design and drafting, foundation, classic, premium on there. And then I'll also bung the rest of the videos on here. So it'll be the sheet metal, the frames and the welding, and the key shot one. I will pop on the end on here now. Thank you.